I always have to wait till it connects. Now it's fine. Now you live, so please go ahead.
Thanks. Yeah. So, welcome. We can start, right? Okay. So, my name is Martin Landa, and I will be with you now and the next workshop also. I mean, both workshops which are related to GRASS, GRASS GIS. Originally, I mean, the plan was that there will be Markus Netteler, my colleague from GeoHarmonizer project, and most importantly, my colleague from my friend from GRASS community. Unfortunately, Markus has had a serious health issue, so he couldn't join. He cannot participate. Regards, Markus. So we decided with other people from GRASS community that we will take over. There is Vero who helped me with materials a lot. So thanks, Vero. I would like also to thank my colleague Ondřej Pešek who helped me. So we were able to like prepare materials in like zero time almost. So let's start. So okay, it should be up somewhere to. It didn't show. Okay, here. Okay, so I need to share the screen first, right? Yeah. So now the screen should be shared. So I will just. This is not my computer, so it will need. I need to clean it up a little bit, just to close everything what is not needed. So first of all, I mean, it's the same or probably same for all workshops you were following. As a first step, we will update our materials. So if you go to files here, you should have already in ODSE workshop work there directory code, and there should be ODSE workshop 2021. So you enter, you can launch terminal here. Terminal should appear. Maybe I will just increase the font first. So let me increase the font. Okay, here. So I will increase it that it's visible. Okay, so I am inside of ODSE workshop directory, and you just run git pull. It's probably nothing surprising for you. So if you check the folder, then there should be a directory which is called GRASS training, GRASS GIS training. You will find materials which we will use. So if you go inside, there is index HTML, and you can open. So I will just wait when it's open. Yeah, okay. So the materials are available like offline from the VirtualBox, but I mean, you can follow them also online. So if you go to the address which I shared already in the MetaMost, so you should know it. So geo and so on, GeoHarmonizer, and there is a ODSE directory, and there is a GRASS GIS directory where the same materials are available. So even that, I mean, in the case that you are not using VirtualBox or in the future you will want to follow these materials, you can, because they are online. Yeah. So this is the first step. The second step, which I already mentioned in the MetaMost channel, you need to download the sample data. And this is a little bit problem because I am not using my computer now, so I need to download them now. But I think it should be quite quick here. It's almost 700 megabytes. We try to prepare the sample data set as much tiny as it was possible. So I will just download it. So I will start downloading, and meanwhile I will be describing what is waiting to you. So I will download it probably to ODSE work there, that it's in one directory. But I mean, you can download it to downloads. It doesn't matter where you download it, because we will be running Grass not from Docker environment. I mean, now we step out from Jupyter notebooks. We will be using software like on OS or operating system level. So I will just download it to ODSE work there. So it will take, it's super quick here. So yeah, it's just a few seconds. I need to wait. So please download it. It's needed, and this is the first important information, because when together with Marcus, when we were preparing or discussing this workshop like more than half hour ago, maybe more, we decided that we will focus on a new version of Grass, or new generation of Grass, which is Grass 8. And yeah, we were optimistic. I mean, the original plan was like a 1.5 years ago. It was decided that the Grass 8 will be released somewhere in spring this year. You feel that spring is slowly over, and the summer too. And Grass 8 is not released yet. When I was preparing this workshop with Vero and others, we felt that it's a good idea to use Grass 8, even it's not still released, because Grass 8 is a new generation. There are cool features, especially for newcomers, because Grass, every software has advantages, disadvantages. There is reason to use Grass, but not for everything. If I want to access quickly geospatial data, I want to display them. I want to create some map compositions, and I want to print them, or I want to perform I want to perform like well-known GIS tools. I would probably use QGIS, because QGIS, now in open source GIS, it's like a mainstream software which is used. It's designed for wide range of the users. You can meet users of QGIS in governmental agencies. You can meet users or QGIS users in almost everywhere. It's software for professionals, but it's also software for the users who are not GIS professionals. It's intuitive. It's easy to load the data. You just drag and drop. You have layers in different, or you have data in different coordinate system. QGIS performs on-the-fly transformation, which is, fancy for the user. But when you start to perform serious computing, you will discover that the on-the-fly transformation is not so cool, and so on. When to use Grass? Grass has a really strong computational engine. It supports raster processing in 2D and also in 3D. You can work with 3D raster data. Yeah, sure. Yeah. When you want to work with topological vector data, Grass is a good choice. If you want to work with imagery data and you want to perform like object segmentation and other similar tasks, GRASS is great. If you want to work with a space-time datasets, GRASS is great. So it makes sense to use GRASS. It's a really powerful software from the computational point of view. You can process large data sets. So it's really powerful. Many users are combining GRASS and QGIS. QGIS is easy to using QGIS, you can easily access data. By GRASS, you can perform fancy computation. This is also reason why, I mean, in QGIS, if you go to the processing, you can find also GRASS as an external provider. So you can basically run also GRASS commands from the processing in QGIS. There are of course these disadvantages which are related to the how GRASS is designed, and we will explain it. We will explain it at the beginning how GRASS works, because this is the main obstacle for the newcomers. And that was also the reason why we decided to use GRASS 8, because I mean, when or one of the important goal for GRASS 8 was like to decrease obstacles for newcomers. So when you run GRASS 7, I mean the current version, you get the startup screen, and you need to fill the startup screen. You need to understand how GRASS works. So you need to read the documentation, you need to understand it. And you know, as a newcomer, most of users are lazy to read the documentation. It must be intuitive enough and so on. So in GRASS 8, we did important steps to decrease the obstacles, or to remove them. That, I mean, it's easier to run software for newcomers. It's we hope that it's easier to understand how GRASS works. So if you know GRASS a little bit, you just started at just in the past, you started. Now you can compare what changed. Yeah, the first part you can just read here. I'm not sure why the YouTube video is not okay. Here it's loading. GRASS GIS is also special software from a history point of view. It's not so common to work with software which is older than 30 years. GRASS has the same age as me. It was born in around year 1981, so it's really old piece of software. It was originally developed for not only for U.S. Army, basically for U.S. Governmental agencies. The development started in U.S. Army construction engineering research laboratories. I mean, the people in this office, they were in like 1980, they were searching for the software which they could use. They didn't find anything which I mean which would be suitable for their purposes. So they started to write their own software. It was from the beginning public, but I mean, yeah, we can speak about this for longer time. But I mean, I think it's important to start GRASS and to start to use GRASS. But it's good to know that GRASS has really fruitful history, and that there is a nice or visible connection to OGC. That OGC was basically born by transformation from Grass Foundation in 1992 or 4. So there is, I mean, from history point of view, it's a nice example. You can show how GIS field changed since 80s. Yes, it's still used, but I think it's more currently it's more used in Europe, but in US it's of course still used. There are developers who are working in North Carolina University. So I mean the grass is developed and used worldwide. So it's still used. Maybe in free time, watch the video, because you will have a clear image how GIS worked in 80s. It's I mean the video is from 1987, so it's nice example, I mean, for the students, because you can have clear image how GIS worked in 80s and how it was, I mean, yeah, how it changed. So I will just skip this first part, and the important is that unfortunately, as I mentioned, GRASS 8 hasn't been released yet. It's planned till the end of this year. So it's I mean, we are very close, but I mean, it's not released yet. So when we were preparing this virtual box, we decided to install it from the binaries which were compiled on this machine from the source. So it's not easy now to install GRASS 8, because I mean there are no binaries yet for Windows, unfortunately. So there's only one way how you can install it. You can compile it from the source code, which is not easy task for a normal user, but it will change very soon. I mean, in a few days, or let's say in 1 week, 2 weeks, there should be release 1, release candidate 1 available, and then you can install it normally on Windows, either from OSGeo for W environment, or you using standalone installers. As I mean, if when I go to GRASS website, it's very easy to install GRASS. You have, I mean, GRASS is available in many Linux distributions. On Windows, you can install it, as I explained, using standalone installer, or using OSGeo for W environment. Maybe what is important, if you install on Windows QGIS, you have GRASS already installed. This is very important news. So if you have QGIS, it depends. I mean, in OSGeo environment, you can install it without GRASS, but normally, if you use a standalone installer, or you use Express option in OSGeo for W environment, which is, I mean, normally user will use the most simple way how to install. So by default, GRASS is installed together with QGIS. So this is important thing, that I mean, then you don't need to install GRASS separately. So hopefully the situation related to GRASS 8 will change very soon. For now, I mean, depends which version of VirtualBox you have. So if you have the second version, you should have GRASS 8 already installed. If you have older image, you need to install it. So please first what you please check if you have GRASS 8 installed. So how you open terminal and write GRASS space 2 dashes version like this. So it should print some information about the software. And here, the first line is the most important. You should see 8.0 def. If you don't see it, you need to install it from the binaries. So I will show you how. So, okay, you need to unzip the file you downloaded. So this the file which I posted to Mattermost, or I mean there is, if you go to the first page of the workshop, there is a sample data section, and in this section there is a link which is pointing to the zip. So you need to extract. I can extract here. So you need to extract the data. So I will wait for the data extraction. And if you go, then you go to the GRASS GIS data directory. There are two subdirectories. The first one, geodata, contains the sample data which we will be using, during this training session. And the second directory is GRASS 8 bin, like binaries. So here are precompiled binaries for this session. Here's a README text file. So if you open in the text editor the README, you see the command which you need to run. So you open terminal, which is important. You open terminal in GRASS 8 bin directory. This is important. So in a GRASS 8 bin directory, I will open terminal like this. So here you see that my current directory is GRASS 8 bin, and I just run this command. It will ask you for password, the password of the user, of the current user. So you just type ODSE # 2021. Yeah. So ODSE # 2021. Yeah, the keyboard is a little bit different, so I will fight with that. Yeah. So after running this command, you should get GRASS 8. So if I run here GRASS version, I should get GRASS 8. Yeah. But I mean, if in the case that you are using the most recent version of the virtual image, you have already GRASS 8 there, and you can skip it. Do not run GRASS from, I'm not sure, maybe GRASS in the first version of the VirtualBox, there was GRASS 7 still installed. Maybe you have the icon of GRASS on the left side. Don't use it. We will use GRASS 8. This is important. So you need to run GRASS command from the terminal. Okay. So let's start GRASS. So this is the first steps. So here you can see how GRASS behaved in the past, or in version 6 or 7. When you run GRASS, you get the startup screen. There are three items you need to fill. You need to understand what you are filling. There are some helper text, some in the green, in the gray color. You have explained what you need to fill, but truly to say, many users were confused from that so much that they even didn't start GRASS at the end, because they didn't understood what they should fill. Because I mean, users are used to start software, and the software starts, and they feel satisfied. GRASS, I mean, software starts, and then they try to use it. Here, GRASS didn't start. It just showed startup screen, and you needed to fight with that. So this has been changed in GRASS 8, but still, I mean, the way how GRASS behaves, how I mean, GRASS motivates you to organize your data from early beginning. So forget that you have shape files, TIFF files, GeoTIFF, some around everywhere on your desk. You drag and drop them to the map canvas, and GRASS will display them and will perform the on-the-fly transformation. From the reasons which are explained in the documentation, GRASS behaves in a little bit different way. It really tries to motivate, or it tries user to learn that I mean, it's good to organize the data. It's good to work with the data which are referenced in the same coordinate system if you use them for computation. And GRASS is a computational software. So it really trying to push you to really to think about the data, what you are doing, what you are using, why you are doing the steps you do. So it tries to, you need to think a little bit what you are doing. Yeah, so I go back to the GRASS. Okay, so from the terminal, I run GRASS command. So if you run GRASS, you will not get the startup screen. What changed the GRASS starts? I mean, the GUI starts. This is important. And I mean, usually or very often, GRASS is used as a server-side application, that you are running GRASS on the server, and you are basically communicating with GRASS only or using command line interface. You are typing commands. But I mean, for newcomers, the GUI is maybe better choice. And I mean, here in this training session, I will try to use GUI as much as possible to show you that GRASS has a GUI interface, and it's quite useful. And I mean, you can communicate with GRASS also in this way. But I mean, here behind you can see real terminal, and I mean, I type r dot, and I will get all GRASS commands, GRASS tools, which are designed for raster processing. So this is, let's say, normal usage, or quite normal usage, that you just log into the remote server and you are running commands from the bash script or from using Python API. But okay, let's go back to the graphical user interface. So you are not getting startup screen. So this is the first important change, that the environment shows, and the user is less nervous, let's say. And well, this is strange, because, well, there is something wrong, because I should get. This is strange. Maybe Leandro was testing. Maybe Leandro was testing GRASS and he didn't close it, because you see that there was someone in the. I mean, there was some user who was testing that and he didn't close it. Yeah. No, it was. I think it was Leandro, because I told him please test it, but he forgot to close it. And now GRASS remembers that there was someone who was using the last map set, and the session hasn't been terminated normally. Yeah. So, but that's not problem. Let's ignore it. But normally, I mean, under normal conditions, where is the here? You should get this. You should get some like a default project. I will now use project term, which is more, I mean, understandable. But later we will explain that there are GRASS location and GRASS map sets. But you can imagine location as the project. It's simplification, but I mean, for now that's I think fine. So there's some default project worthwhile lat long WGS 884 location or project, which contains generalized world map. So the user sees something, and now you can explore how to use software. So you don't need to fill the startup screen. You just start and you try to use it. No. Yeah. Back to I'm wrong. So where okay, here. So here I see another, well, here you can see the tooltip which should navigate you what you should do in the next steps. So learn more or create new location. Yeah, because you need to understand that when you start to use Grass and you have your own data, you should create your own project. This project, this default one, is not designed to use, I mean, for the real usage. It's just the starting point that I mean, the demo map can be displayed. But I mean, the first step or next step is to create your own project, your own location. Yeah. So let's try it. Here you see slightly, I'm wrong. You see slightly different tooltip. Yeah, because there was someone who already used Grass and didn't close normally. So you don't see create new location button. You see switch to the latest used map set, but that's not problem. Here's the most important toolbar for now. By this toolbar you can organize your data, and here the like a fifth icon from left, this like a word with a plus sign, is designed to create new location, new project. Yeah, so I use this icon to create new location, new project. So you will get the location wizard, which helps you or navigates you in order to create a new location. So you define the name. So I will name it like work ODSE workshop 2021. It's better, I mean, to use like ASCII characters only, but yeah, it's recommended, let's say. So I will just use the that's short name. It will be basically the directory which will be created somewhere on your desk. And this is wrong because here you see this is not a good idea. Yeah, because our location would be created in a temporal space. So this is not good. So what we will do, because this is really extraordinary situation, because you just ran Grass and you didn't close it successfully. So I hope, let's try to switch to the latest used map set, and it should switch to the worldwide location which were used last time. Yeah, so switch. Let's try that. Let's hope that it will work. So switch to selected map set. No, switch to current. No, okay, switch to selected map set, and it should switch to the, yeah, perfect. Okay, so we are here. You see that we switch to the word lat long location, and this location is located in Grass data directory. So this is also important. This data directory is created by Grass automatically. In Grass 7 you need to define it, but here we decided that most users at the beginning they don't care. They just want to start Grass. So this data directory which is used by Grass to organize data you are accessing in Grass is located in, or it's named in as a Grass data. So if you go to the files here and you go to home, you see Grass data here, and here you see directory which is called exactly the same as the location. Don't enter and don't delete files. It would be the same as you would go to like to S3 file geodatabase, and you would start to deleting some files which are inside. Yeah, it's not good idea. So we are back. So now let's create location again. Yeah. So here, the icon to create, I will show again. It's this fifth icon from the left. It's explained in online materials, so you can follow. So I will just set up the name. Description is optional. It can be longer sentence, but it's optional. Only what is required is the name of location. So yeah, so this is first important thing which need to be understood by the user. Location or the project is defined by coordinate system. It means that when you are creating a location, you need to decide in which coordinate system you want coordinate system you want to work. So there are more options, of course. Usually, and you know that, for example, in our case, we want to use European terrestrial reference system, which is code. We will use code EPSG. We will use EPSG code 3035. So either you know where you want to work or which coordinate system you want to use for computing, or you have input data and you want just to use them as the source. Yeah, so you have the geotiff files, you have a geopackage file or shape file or whatever, and you just want to create location which fits to the coordinate system in which you have data. So these two options are most common, let's say. EPSG. So next, so we know where we know which coordinate system we will use. So here you type 3035 because we know. So you choose 3035. Then software will ask you about datum transformations, which could be, very important if you work with national coordinate systems. You know that it's important to define data transformation. This is important because if you do mistake, then all data located in your project will be shifted, or there could be problem you can cause by the fact that you do mistake here. So it's better to relax to check that is everything is okay. In this case, it's easy because the datum transformations are 0. Compared to WGS 84 ellipsoid. So we just choose the default one. So here you get the summary, so you can check. All the settings. You see that it's EPSG code 3035, and here you basically see the approach, the definition which is used by approach library, which is used by Grass for if you are performing transformations or reprojecting data, then Grass is using approach library. So now you finish, you are really very close to in order to create a new location. So finish, and When you create location, Grass will immediately switch to the new location. Yeah, so it's just informing you that the current location is ODSE Workshop 2021, and you are in permanent workshop map set. Sorry. So it switched. Maybe one small note about graphical user interface is you see the GUI is designed as the multi layout or yeah, multi layout. You have multiple windows, which is, I mean, there are advantages and but also disadvantages. The big disadvantage is that, I mean, here this is important. Here there are different tabs, and it would be good to have data and display tab visible, like that you can see both of them. It's like in QGIS. Data tab could be, it's like a browser in QGIS. Display tab is like a layers panel. There is a Google Summer of Code project which was related to the single layout. So Grass it's planned for 8.1. In the version 8.1, you will be able to switch between multi-layout window and single layout window. Vero will be for sure speaking about that. There's a presentation and on Wednesday about Grass 8. But okay, there is no Grass 8.1. There is even no Grass 8.0. So you need to wait a little bit. So yeah, so now another step is to import data. Yeah, and I mean, now you don't see the tooltips because Grass understood that you already used Grass before and you don't need tooltips. But I mean, if you really start Grass like the first time, then you will get, and when you create location, maybe I don't have screenshot here, but you will get the tooltip. Hey, you are in the new location. Now you should import your data into the location or into the project. So the really tooltips are helping newcomers to understand what to do. Okay, we are not newcomers apparently, so we have no tooltips. But okay, it's easy. Here in this toolbar, you have two icons to import, or three icons. This one, the third one from right, it's for raster data. If you want to import raster data, vector data, and here is the rest. If you want to link external data, this is important thing. I mean, if you import data into Grass, it means that the data will be converted to the native Grass format. So be aware. I mean, if you are working with terabytes of, for example, Sentinel data, it's not a good idea to import them because then you need a really large disk. It's better to link them. Grass can read data in external formats, so data can stay in the original format, and Grass will be able to read them. Well, yeah, the cost. There is some cost. Grass is using GDAL to read on the fly. I'm not sure if there are some benchmarks, but I mean, the processing sometimes can be a little bit slower, but I don't have numbers. I mean, it's link. I mean, if you work with raster data, it's better to link, because I mean, then you are saving data on your desk, or a space on your desk, because then if you just import, you double the data on your desk. So raster data, it's safe to link. It's safe. It's working. I mean, it's normal to link raster data. With vector data, it's a little bit different because I mean, Graph's vector engine is designed to work only with topological data. So you can link like shapefile. It will work for points. It will probably work for lines, but if you have polygons, then it will many tools will not work properly because I mean, if you link simple features, Grass will build its so-called pseudo topology. So it tries to build topology on the top of simple features data, but usually it's not enough because I mean, if you when you importing vector data, the import process will take simple features and it will convert it to topological data model, and it will perform also cleaning. So if you have polygons which are like overlapping, that there are small overlaps which are behind the threshold, then these overlaps are removed. So I mean, when you are importing vector data into Graphs, it means that the data are also there's a step in which the data there's cleaning step. That I mean, you are getting data which are topologically correct. So if you don't do import, this cleaning cannot be performed because you cannot modify simple feature data. So it depends. I mean, raster, it's recommended to link. With raster, there are no issues, or I mean, there can be of course tool which can work. I mean, there can be small issues, but I mean, from generic point of view, it works, and it's no. I mean, it's normal that I mean, if you work, for example, with imagery data, which we will do in the second workshop, you link them. You link them because you save this disk on. I mean, you save space on your disk, and the performance will be very close to the native format. With vector data, it's more difficult because usually the data are simple features, and Grass is not able to work with simple features. It really requires topological data. I will explain later. But yeah, with raster data, it's recommended approach. I will show in the second workshop. So please wait. Thanks. Okay. So let's go back. So I will import, for example, vector data. If you go to ODSE workshop, the data which we downloaded, you go to geodata. There is ODS styles. So these pilot tiles you are using maybe yesterday. Two tiles. One is in Netherlands, and one is located in Greece, I think. So let's import this file. So I choose import vector layer. I will do import now. Yeah, I will not link because I mean it's an introduction, and we will be working with really small files. We will be not working with terabytes of imagery data. So we will just perform import. Yeah. So you get this dialog here by the browse button. You choose the file you want to import. So I go to home, not literary, GraphGIS data, geodata, and here I choose ODSE tiles. So here you see. You can see important information here. The projection match. Yes means that the input data are in the same coordinate system as your location. If you see no here, don't be scared. It just means that GRASS will perform reprojecting, or GRASS will reproject data when importing. So if you have input data like in WGS84, and you will import them into location which is using, for example, this EPSG code 3035, it means that the input data will be reprojected from WGS84 to European terrestrial reference system, which is the GRASS is really forcing you to work. If you are later performing computation, GRASS is forcing you to work with data layers which are in the same coordinate system, which is important. So, of course, you can create for each project or for each coordinate system in which you want to work, you need to create separate locations, and you can copy data between locations. I will show you afterwards. So I need a little bit to speed up because we have delay. So I imported a vector layer. It should be shown. Yeah, it's here. Here you see these two rectangles. So these two tiles. So maybe let's do the really simple thing. There was the word map in the default location. So let's try to copy this layer from the word wild location to the current. So you go to data tab. This is important. I mean, these two tabs, as you see here, are important. Data is the center point. This is the reason why it's first. It's also changed in GRASS 8. That in GRASS 8 the data tab has been really significantly improved, and now it's a center point. So here you see the second location, the word wild. So I go to word wild. I go to permanent map set. Yeah, this is the first time I use map set. What it is? Yeah. In the documentation, it can be simplified, or it's simplified as a sub project. It's basically something which helps you to organize your data within one project. Let's imagine that you have a project on which, I mean, more people are working. So you have colleagues who are working on the same project as you. So you create a location on the shared disk, and it means, for example, each colleague can have her or his own map set. So map set is like a working place, or not workspace, but I mean it can be used in this way, that I mean each user, each your colleague will have separated map set. Important is that GRASS, when you are creating new data, GRASS is storing data always to the current map set. Yeah, so this is important point. And also, I mean, from this point of view, it's important that that there's only one user who is in the map set inside, because if there will be more users in parallel, they can rewrite data like crazy. You just create a layer, other user will rewrite it, and so on. So GRASS will not enable to enter map set which is locked, and locked means that there is some user inside. So it can be one example of usage, or you have a project and you are doing different kind of stuff. So for each task, you can create separated map set, and then you can organize your data or your work more efficiently. This permanent map set is created automatically. So if you create new location, Grass will create automatically permanent map set. Permanent is called permanent because it don't delete it simply. In the GUI, you cannot delete it. If you go to disk, you can delete it, but don't do it because then location is corrupted and you cannot use it. Well, it's not prepared. I'm just working with local data. Yeah, by GDAL, yes, because I mean Grass is supporting basically everything what is supported by GDAL. So if you run R import and you point input to the URL where cloud optimized generative is located, you can import it. But yeah, it should work. So okay, let's go back. So what is the task? We want to take the country boundaries, the vector layer from word location, and we want to copy it to the current location. Yeah. So I just take, you need to copy, because I mean, copy means that in the case that locations are using different coordinate system, then Grass will do reprojecting. So copy, and here I go to the map set, to the current map set, and here I will choose this. Okay. Here's a dialog where you can set up. This is just for vector data. Here you are defining maximum segment length. It means that in the case that in the data there will be lines which are longer than 10 kilometers. There will be split. Yeah, because when you are doing reprojection in one projection, the line can be straightforward, but if you do reprojection, it shouldn't be like a curve, but at least it will be approximated. Yeah, I will keep the default one. So unfortunately, the data are not displayed automatically. It would be maybe better, but from educational point of view, it's not so bad, because I will show you how to display data which you have in the location. So here you see, if you go back to the data tab, you see that new layer appeared. So you click on by right click, you get a contextual menu, and here is a display layer, or simply double click works. So if you double click, I get layer. You see that, I mean, grass, I would not use Grass for showing data. Yeah, it's very simple. It works, but it's simple. Grass is for computing, simply. So if I want to change the order of the layers, because I mean I want to display tiles on the top, so I go to display tab, and here you see these two items, because you have two layers in a map display. So you just by drag and drop, this is the first time, but unfortunately Tom is not here, the drag and drop is working. So here, so yeah, but still it's not so nice, because I mean everything is blue, you know. So let's change at least the color, the fill color of the tiles to see something. So how to do it? You choose the layer, you go to properties by right click, or double click works also here. So double click. Yeah, this is strange, because here this is not happening on my computer. I'm using GNOME 2, and the windows pop up, but here the window was hidden, so I just took it. So here I go to colors, and here is the fill area fill color, and yeah, I will choose red. Yeah, so you see these two. Maybe I can zoom in a little bit. Zoom out. Okay, zoom in a little bit. Yeah, something like this. So you see these two red boxes somewhere in the Netherlands and in Greece. Yeah, so we are able to get our data into the location, into the project, and we are able to simply, to perform simple visualization. Yeah. So now, this next step. The next step. Yeah, here. The next step. For computing, we will also use some sample raster data, really small, tiny. So let's import a raster file for Greece. Greece will be maybe better for our purposes because there will be more fun related to slope and so on. So we will choose the Greece, the tile of 5606. So let's import the related tile, DTM. So I go back to Data tab. If you want to import data, go to Data tab, choose this icon, and choose data. So I will choose DTM 5606, and yeah, it's the projection matches. It's in the same location, in the same coordinate system. So you got no. Now in this case I imported. So here is DTM. Maybe I will just change order here. So maybe I will change the properties. You know how. So maybe fill color will be transparent, and feature color will be like red to see something. Yeah. So here's our tile. It will be area of interest, and we have data, and we can start to do really simple computation. It's just a showcase how to use graphs, but we will use really small data. So yeah. So maybe this I will skip because time is running here. Here is explain how graphs works with a vector topology. There are like topological primitives like nodes, lines, boundaries, centroids, areas, isles. So you see that maybe I can show here when I imported ODS styles. If I go to display tab and I show metadata, I am not getting like information. There are two polygons, there are two areas, two islands, two boundaries, two centroids, and so on. And sometimes it can be much more, you can have more fun because it doesn't mean that the number of areas will be the same as the number of polygons. Don't think that it works like that. In this case, it's just a coincidence which is related to input data which we are using. Okay, but yeah, but we need to go on because time is running, as I explained. Yeah, here is note about linking, how to link, and yeah, this is important. I explained at the beginning that we will be using graphical user interface, but for graphs, the rule is that everything you can do from the command line, everything. Not everything you can do from GUI. So the next step is about how to work with tools, how to perform computation in graphs, how it's organized, what is computation region, because in every GIS you use, ArcGIS, QGIS, if you are performing raster processing, there is some computation region. But usually softwares like ArcGIS or QGIS, they are behaving in the sense that they are setting up computation region based on input data. Grass is opposite. Grass is behaving in different way. You need to set up computation region. This is the most common problem or question of the newcomers. I imported raster file or raster layer. I computed slope or whatever, and I am getting empty layer with a one pixel with no data. It's buggy software. No bug is on your side. You need to define computation region on your own. So, okay, how to find first? How to find tools? How to perform them? Let's do simple thing. We will try to create a buffer around a selected tile. So we will take a tile 565606. We will select it, and we will create a small buffer like 1 kilometer around the tile, and this region will be used as the computational region, and we will try to perform our computation in this area of interest. So let's go back to graphs. Yeah, so yeah, you need to go to modules tab. This tab maybe could be renamed to tools, which could be maybe more readable for the users. But I mean, in Grass terminology, tool or tool is called module. It's Grass is modular system. Basically, the GUI which we are using is module. Is one of the tools. This is maybe good to mention. If the GUI crashes, then you can run it from the terminal by g.gui command. So here you can search by the keyword. I type buffer. Yeah, and I'm getting all commands, all tools which have a buffer as the keyword. So yeah, and it's quite readable. I mean, here in the brackets, you can see how the tool is called when you call it from the command line. So I mean, the GUI is really designed that it helps you to understand how to call commands from the command line, or how to call commands from Python API. And each command, it's explained in the materials. Each command starts with a prefix. R means that the tool is designed to work with raster files or raster data. It's basically performing raster processing. V dot vectors R3 means that these tools are working with a 3D raster data. T dot means that these tools were designed in order to work with a space-time data. E dot it's for imagery, and so on. So it's organized. Each tool has a prefix name and description and so on. So, sorry. Well, the imagery tools are usually like classification, object segmentation, and so on. So the tools which are designed for EOD data. R is a more generic, like computing slope, computing raster buffers, and so on. Yeah. So we want to create vector buffers, or we want to work with a vector data. So I choose a V buffer. I run it. It shows the dialog. And okay, I choose the input data. It's ODS tiles. From these two tiles, I want to select the tile in Greece. So I go to selection, and here is a var statement, the third parameter. So I can, of course, type, or I can here use the builder, the simple builder. There is one obstacle. which is, I mean, which should be changed because it's for newcomers, it's misleading. If you click here, you will get the error. You need to choose here in the first parameter. You need to change -1 to 1. I will not explain now because it's really no time. It's related to the fact that you can connect more attributes tables to the single vector layer, not only one. And by one, you are telling I want to use the first attribute table which is connected. So here when I click, I get, yeah, this is not nice. Okay, I'm getting builder. So here is a tile ID. I can get all values. Here I click. I just simply build a where statement. Okay, apply. So here by the where statement, you can select the tile, and here you go to distance. Unfortunately, vBuffer, it's quite not complicated module, but you see that there is really a huge number of parameters you can set, and sometimes I mean in this case in such cases it's sometimes difficult to find the parameter because you have a lot. I mean, vBuffer has more than I don't know 15 parameters, but I mean the most important parameter is the distance. You select how the buffer will be created. So I will use 1000. It's a 1 kilometer. Yeah. So, and here what is important here in the status bar, you see how the command would look like in the command line. So this teach you how use graphs from the command lines. Then you by copy statement copy button, you can copy commands to the text file, and you can collect the commands, and this will be probably the first step to do some automatization, because you can create a bash script or bat script on Windows. So this could be like a first step to do some automatization. Yeah, I need to fill also output, right? Because yeah, so I will call it tile 5606. So you define the output name. So run. So you should get the result or the result. The output should be automatically displayed in a map display. So maybe let's change the properties. Let's change the properties. So it will be fill color transparent, and outline will be red. Yeah. So now how to set up the region. If I now okay, let's try first maybe, because let's yes, but I mean it's 15 minutes to the end. No, I'm speaking the whole time. Yeah. Okay. So let's set up the region, because I mean if I explained that all you need to remember that all R tools, or the tools which are start with R, they are always computing in current computation region. And okay, where is current computation region? You can see the current computation region, for example, by this icon, the zoom, this icon with two crosses, which zooms to the current computation region, and you see that it's somewhere else. It's not in your area of interest. So if I run R, if I just perform slope computation, it will be computed here, not where I have data, but here. So first thing is to set up computation region. Of course, I mean, there's this advantage that you need to take care about your computation region. This is this advantage, but it can turn easily to advantage, because if you set up, you can be sure that grass will not change it. Yeah, so you set up and you run any kind of command and you will produce data in the same coordinate system regarding input data. So how to set up? Easy way from grass, because the grass GUI, because we have like 15 minutes. It's just from the contextual menu to run to choose the set computation region from selected map. Grass GUI behaves in the way that on background there are always tools which are called. So if you click here, grass GUI will call G region command on the ground. So if I now zoom in to the computational region by this icon, I should get back the data in my map display. You see also, if I zoom out a little bit, you see that the computational region as this is highlighted by the red line. Yeah, so you see that the red line is following the raster extent. Maybe I will change the color of the tile because it's misleading. So I will change it to yellow. So you can control region extent visually also by this red line. So yeah. So now it's the now it's the right moment to compute something, because I mean we created project, we imported data, we set up computational region, and we can perform computation. So I go to modules and let's do really something simple, because I mean this is introduction and we wanted just to show you how grass is designed, how to work with the grass, what are really the first important steps to understand it. So slope, I will write slope. I want to compute slope. So yeah, there is a R slope aspect tool, which I mean this tool you can use for computing like not only slope aspect but also other derivatives or products computed from digital terrain model. So you run and okay, the input is the tile which I imported, and yeah, the output will be like a slope, yeah, or I can call it slope tile or whatever. Other outputs I will skip. If I don't fill it, they will be not computed. So I run and I will get the slope. You can see that I got the slope computed in the current computation region. Maybe let's change as yeah, just to show you how to work with computation region. Let's try to set up a region based on the extended tile. Yeah, so we will basically set up the region based on the vector map, vector layer. So it seems to be quite easy. You just select the vector layer you want to use for setting up the computation region. So you do that. Okay, you see that the red line overlap the tile, that the current computation region is a little bit smaller. There is one thing you need to be aware. Okay, if I go here to, I will choose show computational extent. No, sorry. The third item, computational extent. The input data has a resolution of 30 meters. But if you now check the computation region, you see that that computation region is almost 30 meters. it's quite logical, because I mean, you set up computation region by using bounding box of the vector map. So the resolution changed a little bit in the computation region, which is usually something you want to avoid, because if you keep the computation region in this way, GRASS will, before a computation, it will read it. I mean, other softwares behave the same. ArcGIS, QGIS, it will behave the same. You have computation region set up, you have grid for computing, which will be used for computing. You have input data, and in the case that that input data, I mean, the grade of the input data differs from the grade which is used for computation, then usually software will perform some quick resampling, which means basically the nearest neighbor will be used. So this is something we want to avoid, right? Because we want to create a slope which has the exact the same spatial resolution as the input data. So we need to a little bit like enlarge the computation region that it fits the grade of DTM. So this is the next step. So you choose the raster file which you want to use for alignment. So you want to align computational grid based on input data. So you choose the raster file, and here you don't set computation region, of course, because then you would set up back to the original computation region. You want only align. So you want to change. You want to a little bit enlarge computational region, little bit move the grade that it completely fits, or it aligns the grade of input data. So align, and here you see that in the status bar it changed to 30 meters. So now we will be computing in our area of interest, and we will produce the slope product which fits align the input data model. So let's go back. Let's run the command again. What is good, maybe I will show, if you go to console, there is a history of commands. So if I type here arrow, I will get the previous command. So you can slightly modify it here, and you can run it from console, and you don't need to click again. So I will call it tile underscore AOE, like era of interest, and I don't need to fill all the parameters. I just change what I want, and I press enter. Yeah. What is a little bit disadvantage if you call it like from console? The resultant data are not automatically added to display. So we need to go to data tab, and yeah, you see here the new layer. Sometimes it can happen that you need to refresh data catalog. That I mean, sometimes GUI lost the track. If I call this command really from the terminal, the GUI will not know it. So sometimes you need to refresh. There are two icons. The second is better usually, because the second will refresh only the tree or the layers maps which are in the current map set only. Try to imagine that you are really working with a time series data. You have thousands of layers, and you don't want to you have more map sets and more locations, and then to refresh the tree, it can help. It can take a time, but usually when you are working with a really big data, large data sets, usually you are using command line interface, not GUI. But okay, let's display. So here you see that the slope has been really computed in the current computation region. So we have like 6 minutes, which is not so much, because you see that there are more things which were planned. There is another workshop, so there is still important points maybe will highlighted in the next workshop. But let's at least set up the color table. So I will show you how to change the color table. So if I go back to DTM, this is default color interpretation with this. But okay, let's try to change it. So here from the contextual menu, there's a set color table, and here you get the command R colors. It's the same if I would call the command here from the terminal R colors, it would be the same. Yeah, so I mean the tools you run from the GUI, the tools are the same when you run them from the command line. There are no differences. So okay, I want to change the color of DTM. Let me show this. Yeah, I think this with a single layout, it will be even easier to use Grass GUI, because these multiple windows, sometimes they are hidden. Then you leave them open. Then you have 10 windows, and sometimes it can be messy if you use it in this way. So let's go to define. We want to define the color table. There are plenty of options. Usually, it's quite common to use predefined tables. Grass has a lot of predefined tables which were designed by the users. So they are usually useful because users wanted them. So there's a color table elevation. So you get more reasonable colors. Yeah. So let's try. Yeah, this is the last unit. So yeah, so just very quickly, yeah, here you can see that, or it's a just to remember you that almost all, there are of course exceptions, but let's say 99% of the tools which starts with R computes always in the current computational region. Exception are modules which imports data, because I mean this is quite obvious why they are ignoring computation region, because then you would need to set up computation region before importing data, which could be really it would be tricky. Okay, so let's see here. If I just compute like statistics, like for example for DTM or for slope. So let's compute statistics for DTM. So here is Raster Statistics. It's a R univar module. So you see that, I mean, you get a minimum elevation, maximum range, and other information. If I change the computation region now, R univar will always compute in the current computation region. So I will now change computation region interactively. So I go here. It's like here it's like a search icon from right. It's explained in the online materials. You get the menu, and here you can change computation region interactively. And if I go here to the console and I just run command from the history, you will see that I will get slightly different numbers. Yeah, so the minimum is not 0, but the minimum is like 300, almost 60. So this is important. Just remember that all or almost all modules which start with R, they always follow the computational region. Yeah, here it's explained how to work with mask, but maybe, I mean, we will use mask in the next workshop. So I will explain. Here is an example of a simple map algebra. RMapCalc is very useful tool. Yeah. Yes, I mean, it's just it's just copy paste commands. I mean, here you can see that there are screenshots, but I always put the command because I mean the key I mean the important is the command because the GUI can change and you know yeah. So the commands are important. So basically, with map algebra, we will be also working in the next workshop. So just the last few words. GRASS has also graphical modeler, so you can design your workflow like graphically. The model can be exported to Python script. So this can be like really for the user who cannot or who are really not so familiar with Python. They can design the model. They can export the model to Python code, and then they can start to slowly improving the code and so on. So here's example of exported module. The important is that, for example, if I just download this script, I will download it somewhere to downloads, and I will just I will just run the command. So there is this icon which I mean there's a Python editor also, but I mean it's the more easiest to just run script here. So I just find the script, download, slope, and yeah, executable. Yes, this is just that next time the GRASS will know where the tool is located on disk. So yes, and it's not showing graphical user interface. Yeah, this is not a good example. But if I force it by UI, I should get it. Yeah, this is not a good example because yeah, the GUI was not shown because all parameters has default values. So that was the reason why the GUI haven't shown. But I mean, if you do not this, that you define the all default values, then you get the GUI. And this is important that I mean it's good to mention that I mean if you create the model or the script, the Python script, you can define the user interface, and the GUI will render like a normal dialog for other tools. I mean, many tools which we are using or we will use, like RMask for setting up the mask, it's a Python script. I mean, yeah, this is maybe it makes sense to mention that I mean the core engine of graphs is written in C. Many modules are written in C, like rslope aspect which we use. It's written in C. But still there are a lot of tools which are Python scripts. But I mean, every time you perform some heavy computation in GRASS, you can be sure that it's written in C, because then it wouldn't be so quick. Okay, so yeah, so that was the last note. We will repeat part of the things like how to work with the mask. We will repeat on the next two workshops. So yeah, you can follow it's explained in the online materials, everything. And as Tom mentioned, you just copy paste commands. Yeah, sure.